Our topic is SDN, which stands for Software Defined Networking. Highly correlated with NFV, SDN is a big thing in IT and telecom industry. I am going to build your concepts on SDN technology using a very simple graphics and the concepts. The concepts which I am going to tell you are of use for everyone which is working in IT or telecom or networks. While NFV is all about building a virtual platforms, SDN is making IP networks much more programmable so that packet routing is possible with lots of flexibility and agility. As shown here, SDN is based on concept of separating brain and control plane for traffic routing. This separation of brain and controller plane makes SDN a very powerful tool for customizing networks on the fly. With SDN, you can provision new bandwidth and define traffic failovers just like never before. Now let's start our journey with the SDN. There is a lot of confusion between the NFV and SDN. Don't worry, we are going to clarify both the technologies in a very simplified way using the real life examples. Till now we have seen how NFV works in the previous videos, how NFV helps us building the agile and flexible networks using the flexible compute, the flexible resources like storage, the blades, the hardwares. Since the NFV is all about three main concepts, the softwareization, the virtualization and the orchestration and automation. SDN is a different animal. It's all about the networking control function for routing and policy definitions. And this entire thing is done in a very automated way. And with SDN, what we are going to do, we are going to ensure the IP and the network reachability is going to happen well in time. Both SDN and NFV architecture are going to use the network abstraction, but they do it totally in a different way. SDN provides a new level of programmability and abstraction to the network level, which is going to play a phenomenal role in automating the networks. Let's take a deep dive on SDN and let's understand how it works. Just see the building block which represents the NFV and host multiple applications. Just like you can remove, replace or keep a new tenant in the building, similarly you can host an application in the NFV as well. You can see a traffic on the road representing the SDN, whose main responsibility is to carry the traffic in the right destination in a very automated way. First thing first, let's understand why we need SDN and how it is helping. Well, we have also seen this particular example in the previous video, wherein we have seen the NFV helps in virtualizing the network, which help us in the rapid deployment and ultimately reduce our deployment time of new service or new nodes. Now NFV does it in few seconds. But what about network reachability? The network connectivity or reachability is a real problem. For any new node or a new service, we need multiple things such as the IP allocation, the bandwidth allocation, the policy opening, the routing changes, and actually we need to do end-to-end reachability. And for doing that, it takes a lot of time. It takes a lot of time to prepare design, to execute the changes, and we need to do it in every router, every switch. That is also prone to the mistakes. Net for doing the network reachability piece, we takes few days and few weeks. Ultimately, even if the NFV resources are available, but we cannot launch the new service or we cannot make the new node live because our network reachability is not done. The SDN is going to help us specifically out here. Let's understand how SDN works. Well, this is our traditional network where traffic is moving between the various switches and routers in order to reach the final destination. SDN changes how networking is fundamentally done. Instead of having a network intelligence which is distributed in every device, I mean to say every router and switch applying its own brain, SDN aims to centralize the brain. SDN aims to centralize the command and control into a central node. And it is going to distribute the entire thing into a different control plane and a different data forwarding plane. let's understand how this different plane works out there. The first one is the data plane. We also call it as the forwarding function or forwarding plane. In traditional network, in traditional router and switches, there are multiple nodes which are connected to each other. All these multiple routers and switches, they are connected to each other via line cards and the links running between these line cards. This is where data is actually moved from one device to another device. As visible on the screen, the traffic is moving all the way from router A to router B to router C to router D. The traffic is moving from all the way to left to the right. That's how the packets are flowing. We call it as data or forwarding plane. The next one is the control plane. Well, in traditional network, the role of control plane is to take the routing decisions. Every router is having its own brain. You can see the brain in this orange color which is like rotating out there. Every router apply its own brain to decide the best path to route the traffic. These routing decisions are taken on the basis of the routes configured in the router and the routes learned from the adjacent nodes or adjacent routers. For an example, in traditional network, router A decides to route the traffic to the router B on basis of the brain applied by itself, that is router A. I mean to say the router A is taking the decision where to route the traffic. Since router A doesn't know what is happening in the life of the subsequent router such as the router C or router D, this can be a point of concern. I mean to say if there is some problem with router D, router A never comes to know because router A is not speaking to router D directly. It's going via B, C and then ultimately reaching D. And if there is problem with D, A will never come to know. And A will keep on bombarding the traffic in the same direction and it will never route the traffic to a better path. There has to be someone, there has to be absolutely someone who is keeping an end-to-end eye on a complete network and take a holistic decision. That's the power of SDN, where we are going to bring these resiliencies into the network. The last one is the management plane. Now, in traditional network, this is used for performing the operation and maintenance of network. I mean to say you can do the configuration, you can get the reports, you are actually running the network out there. For an example, we use management plane to fetch reports, perform configuration, get alerts, do the alarms. You can see this guy who is logging into every router and doing the configuration out there on the screen. If you have to open a new route, eventually we need to log in into every router and this is very tedious task. It takes a lot of time and this is always prone to errors. Now we have covered all the three plane out there. The data or forwarding plane, the control plane and the management plane. Now let's see how SDN simplifies the life and what good things SDN is going to bring to this particular network. This is SDN powered network wherein the controller or brain of network is separated from the data or forwarding plane. SDN will change dramatically the way we are designing the networks, the way we are managing the networks, the way we are running our networks. Before we discuss this further, let's understand what is SDN. SDN stands for the software defined networking. This is an emerging architecture of the network that is fully programmable, a much more dynamic network. It is manageable, it is cost effective, it is adaptable. It makes it ideal for meeting the dynamic and random requirements. There are 4 key principles of the SDN network. The first key principle is it makes the networking and IP routing flexible. SDN ultimately enables packets or traffic to reach to its destination. It does same with the help of software and dynamic algorithm with full flexibility and agility. Instead of wasting many days in performing the manual routing for enabling the reachability, SDN does it in a better way. Ultimately, it saves a lot of time. The second key principle is decoupling control and data plane. In traditional network, both brain and data forwarding layer sits on the same router. Here we can see the centralized controller in SDN, whereas data forwarding plane is still residing on the router. The centralized controller, as part of SDN, it decides the traffic routing. The data plane is only used for forwarding the payload to the destination. We call it as a decoupling of control and data plane. They are totally separated. The next key thing is the offloading of brain to the centralized controller and the central view of the resources. SDN provides a central view of much more efficient resource allocation, and it is keeping end-to-end eye on the network services. This facilitates centralized monitoring of entire network. The control plane is taking decisions, considering end-to-end topology, considering end-to-end health of a network, while routing a traffic from router A down the line to router B to C to D. It does consider what's happening in the life of router D. In case there is some outage or some link congestion or some problem with router D or some degradation with router D, it will route the traffic via router X. That's the beauty of SDN. It keeps end-to-end eye on the network. Now, in last, the network is much more programmable, it is centrally managed, and it is agile for any need. Centralized control plane means network control to become directly programmable and the underlying infrastructure to be abstracted for applications and network services. SDN makes network programmable so that operator can support multiple applications such as dynamic provisioning of bandwidth, automatic scale out, automatic scale in, building a protection paths, making a new service live, making new nodes live. All of this can be entirely automated and can be made programmable. There are upper layer applications which can flexibly manage the controller, such as exposing controller directly to the user on a web portal where end user can provision or deprovision bandwidth himself. The true power of SDN is the abstraction. The whole logic flow is so automated that network application can make requests to the SDN controller, which in turn will adjust the network resources, change the configuration, and all of that happens in few seconds. And ultimately your new node, new service, new thing which is required out there, maybe new bandwidth, new provisioning, everything is available on the fly within few seconds. Now let's understand the SDN framework, the SDN architecture. As you can see this blue color arrow out there, this is Openflow integration. The Openflow protocol is the key to the entire SDN topology. The group of few intellects, they started working on the Openflow specification in Stanford University, and thereafter in year 2011, the ONF, the Open Networking Foundation, also started working. And they started working on developing the SDN specs to promote the SDN, to promote the Openflow. There are several working groups which are created by this organization, and they all together standardize the entire thing. Most of the OEM and vendors as of now, as on date, they are supporting this Openflow protocol. Here SDN controller can belong from one OEM, where data forwarding plane may belong from another vendor. I mean to say, you put a controller from Huawei, or you put the forwarding plane from Juniper, or maybe from Cisco or Juniper, or whatever combination you want to do, you can do. The SDN controller can also communicate with many type of network elements from different vendors with help of the Openflow protocol. This Openflow protocol provides unified method or southbound interface for the control plane to communicate with the data plane. This is followed by all the vendors such as Cisco, Juniper, HP, all of them. Openflow works on standard API defined between the control and the data or forwarding plane. With help of Openflow, the brain or controller can manipulate the changes in the routing table, the routing algorithm, which are used by the forwarding or data plane. This allows a remote configuration of packet forwarding tables by adding, modifying, and removing packet matching rules and actions in the data forwarding plane. This Openflow needs to be supported by both controller and forwarding plane. The existing devices can also be evolved to support Openflow. For example, if you are having an old inventory of say Cisco switches, Juniper switches, routers, or like Huawei nodes or something like that, you can convert all of that traditional switches into a data forwarding plane. Most of these support the data forwarding plane function. I mean to say, you can convert the traditional network into the data forwarding plane, and you can create a new controller, and that controller can create your new SDN network, wherein your existing traditional networks will be reused altogether out there. Here we can transform our existing network to support SDN. Since controller is exposed to the business applications with the help of APIs, this gives us opportunity to innovate multiple features and functionality in the network as per the customer requirement. Not all the existing traditional router or switches can be converted into SDN. There are few models which are not supported, but more or less, if you have procured in last few years, more or less they can be upgraded to SDN. Now we'll come back to our first slide, where network reachability was a big problem. With SDN coming into picture, we have seen we can get the network reachability done within few seconds. This solves our major problem. Let's quickly recap and the benefits and feature of SDN based networks. The SDN based network, they are directly programmable. The SDN based networks, they are flexible, they are dynamic, they are agile, they are centrally managed, they abstract the network, they decouples the control and forwarding plane based on the open standards, and based upon the I mean to say, they are usually open on the standards. They are supported by more or less all the vendors. They are neutral to the vendor. We have already discussed more or less all of these points in the previous slide. With this, I want to leave a very strong visual message so that you can never forget the difference between the SDN and NFV. Just see the building block which represents the NFV and host multiple applications. Just like you can remove, replace or keep a new tenant in the building, similarly you can host an application in the NFV as well. You can see a traffic on the road representing the SDN, whose main responsibility is to carry the traffic in the right destination in a very automated way. Hope that clarifies the concept of SDN and NFV, and hence from there onwards I am assuming there is absolutely no confusion in NFV and SDN. Well, that's me again. We have covered both NFV and SDN for telco operators. We have also covered why it is cloud and why it is required. In next video, I'm going to demystify the hypervisor versus container mystery, which are going to become the foundation and the building block of the modern cloud networks. Stay tuned to the videos. If you want to download this PPT or video, please visit my website telecomtutorial.info. Hope this video presentation is useful to you. Please feel free to like, dislike, comment and share. Please subscribe to my YouTube channel for more technical videos. Thank you.